Children, let us continue the chapter quadrilateral. Now let us start the exercise 1. Now let us solve the first question of that exercise. What is that question? The angles of a quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. The given ratio is 3:5:9:13. We have to find all the angles of the quadrilateral. You know that quadrilateral is having 4 angles. What is the sum of the 4 angles of the quadrilateral? That is 360 degree. Sum of angles of a quadrilateral is 360 degree. Means we have to divide 360 in the ratio 3:5:4:13. So first let us write the given ratio is. What is given here? So write the solution given. What is given? The ratio of the angles of quadrilateral. The ratio of the angles of quadrilateral. What is that ratio? 3:5:9:13. Then let us take the 4 angles of the quadrilateral are. Let the 4 angles are. 4 angles are. You take according to ratio 3x, 5x, 9x, 13x. As the ratio is 3:5:9:13, let us take the angles are 3x, 5x, 9x, 13x. X is the proportionality constant. We know that what do you know that the sum of angles of a quadrilateral is sum of angles of quadrilateral equals how much? 360 degree. Sum of angles of quadrilateral equals 360 degree. Therefore, you can have that. Therefore, write 3x plus 5x plus 9x plus 13x must be equals to 360 degree. As sum of 4 angles of the quadrilateral equals 360, that is 3x plus 5x plus 9x plus 13x equals 360 degree. Now here what is the sum of 3x, 5x, 9x, 13x? 3 plus 5 is 8, 8 plus 9 is 17, 17 plus 13 is 30. So the sum of this 3x, 5x, 9x, 13x is 30x equals what? 360 degree. Equals 360 degree. This implies x equals, you transfer 30 to the RHS, that becomes 360 degree by 30. Then you can cancel 0, 0, 3 ones are 3 12s are. So x equals what? Therefore x equals 12 degree you got. X equals 12 degree. Then find the angles. Therefore here the angles are 3x, 5x, 9x, 13x. Therefore angles of quadrilateral are first one you take 3x equals 3 into what is the value of x? 12. 12 you write 12 degree or 12 only you write first. 12 3 is a 36. The first angle is 36 degree. Next the second angle is 5x. Second angle is 5x. You take 5x. 5x equals 5 into same value, that is 12. 5 12s are 60. Second angle is 60 degree. Then the third angle is 9x. Then you take 9x equals 9 into 12. 9 into 12. 12 9s are 108, 108 degree. Third angle is 108 degree. Then the fourth one is 13x. Fourth one is 13x. So you take, that is 13x equals 13 into 12. You know that 12 3s are 36. 12 1s are 12 plus 3 is 15. So it is 150 degree, 156 degree. Next you verify the sum here. 6 plus 8 14, 14 plus 6 20. 7 plus 6 13 plus 3 16. 13 plus 3 is 16. 2 plus 1 3. You got 360 degree. So here you got the angles 36 degree, 60 degree, 108 degree and 156 degree. Therefore you write, therefore angles of quadrilateral are 36 degree, 60 degree, 108 degree and 156 degree. These are the angles which are in the ratio 3:5:9:13. Now you take the second question. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So what is given here? In a parallelogram, diagonals are equal and we have to show that that is a rectangle. Now you consider the parallelogram ABCD in which the diagonals are equal, that is AC equals BD, and we have to prove that it is a rectangle, means we have to show that angles are 90 degree. Here angles of a parallelogram are 90 degree, then naturally it becomes a rectangle. Write the solution. What is given? Let given parallelogram is ABCD whose diagonals AC and BD are equal. Whose diagonals AC and BD are equal. That is, here the diagonals are AC and BD and they are equal, means you can write AC is equals to BD. And what you have to prove? We have to prove that ABCD is a rectangle. We have to prove that ABCD is a rectangle. Here we have to show that the angles are right angles. If you proved any one angle is right angle, means according to the property of the parallelogram, all the four angles becomes right angles, then it is a rectangle. So here, for this reason, you take the help of the congruency of triangle. Now you take any one diagonal. Here, take the triangle ABC and DCB, or you take ADC. Here you take the triangle ADC and triangle BDC, and if you prove that they are congruent, the corresponding parts of the congruent triangles are equal, then naturally you will have this angle D is equals to angle, this angle BCD, angle ADC is equals to angle BCD. they are equal, and you know that they are supplementary because they are the consecutive angles, they are the adjacent angles, they must be supplementary, means their sum is 180 degree. Equal and their sum is 180 degree means they must be equals to 90 degree. So you write the names of the two triangles here. Write the names of the triangles. In triangle ADC and triangle BCD. In triangle ADC and triangle BCD. Right, you know that here AD is equals to BC because they are the opposite sides of the parallelogram. And also it is given that AC equals DB, that is given, they are the diagonals. It is given that diagonals are equal and one common side is there, that is DC equals DC, that you can take here. So you write first one, AD is equals to BC. AD is equals to BC. Reason what you can give, opposite sides of parallelogram. Opposite sides of parallelogram. Opposite sides of parallelogram. Next you take DC equals DC common. That is the side of both the triangle. DC equals DC. DC equals DC, that is the common side of both the triangle. Common in both the triangle. Common in both triangles. That is the side of both triangle ADC and triangle BCD. Here this is the side of this whole triangle and also this whole triangle. So that is the common side. Then you write AC equals BD. So you write AC equals BD. Why they are equal? It is given. So you write given. Here AC equals BD is given. So you write the reason given. Now you got side, side, side. According to the Sss Congruence Rule, you can write that triangle ABC is congruent to triangle ADC is congruent to triangle DBC. Therefore, you can write triangle ADC is congruent to triangle BCD according to which congruence rule? Sss Congruence Rule. Sss Congruence Rule. As you got that triangle ADC is congruent to triangle BCD, you can say that angle ADC is equals to angle BCD because according to CPCT, they are the corresponding part of congruent triangles. Corresponding parts of congruent triangle. Then you take, therefore you can write angle ADC equals angle DCB or BCD. Reason CPCT you can give, corresponding parts of congruent triangles. Here you observe angle ADC is equals to angle BCD. You proved by the congruence rule, you proved that they are congruent, and according to CPCT you got angle ADC is equals to angle BCD. And you know the property of parallelogram. Here angle ADC and angle BCD are the consecutive angles of the parallelogram. They must be supplementary. Their sum must be equals to 180 degree. Or one more reason you can take here. Here you know that AD is parallel to BC and DC becomes the transversal of the parallel line AD and BC, and the angle ADC and angle BCD are the interior angles on the same side of the transversal DC you can take. Here angle ADC and angle BCD are the interior angles on the same side of the transversal DC of AD parallel to BC. That also you can take here. Both are one and the same here. So you write angle ADC plus angle BCD equals how much? 180 degree. So what is the reason? You can write here interior angles on the same side of the transversal. Same side of the transversal. And also you can take the one of the property of the parallelogram. Consecutive angles are supplementary. Now here you got that the sum of the angle ADC and BCD is equals to 180 degree and they are equal. Then you can say that therefore you can have angle ADC equals angle BCD, both are equals to what? 180 by 2. So if you consider this is the first, this is the second. So you can take from first and second. From first and second. Here sum is 180 and they are equal means they are equals to what? 180 by 2. So you can have therefore angle ADC equals angle BCD, both are equals to 90 degree. So you can say that ABCD is a parallelogram and one angle is 90 degree. Therefore ABCD is a rectangle. Here ABCD is a parallelogram and one angle is 90 degree, means naturally all the angles becomes 90 degree. So you take thus ABCD is a parallelogram with a angle 90 degree. Therefore ABCD is a rectangle. Therefore ABCD is a rectangle. You got the result here. So if the diagonals of a parallelogram are equal, then it is a rectangle. Now the next question, third question, show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. So what is given, what you have to prove? It is given that the diagonals of a quadrilateral bisect each other at right angles. And we have to show that this quadrilateral is a rhombus. Now you take the figure here. ABCD is a quadrilateral in which the diagonals AC and BD bisect each other at right angles. So you write the solution. Given a quadrilateral ABCD whose diagonals AC and BD bisect each other at right angles. Bisect each other at right angles. Here ABCD is a quadrilateral. Diagonals AC and BD bisect each other at right angles. Now O is a point of intersection of the diagonal AC and BD. And what is given here? AC and BD bisect each other at right angles means you can write that is here AO must be equals to OC and DO must be equals to BO. So you write that is OA is equals to OC and OB is equals to OD. OA is equals to OC and OB is equals to OD. Now what you have to prove? We have to prove that is a quadrilateral, and so it is given that they bisect at right angles means at a point O, at a point of intersection O, the angles are right angles. Means there are 4 angles at O, they are angle AOB, this angle, and equals which angle? BOC, angle BOC, and next which angle? Angle COD. Next which angle? Angle AOD. They must be equals to what? 90 degree. They bisect each other at right angles means here OA equals OC, OB equals OD, and the angle formed, 4 angles formed at a point of intersection O are right angles. That is given here. Now what you have to prove? We have to prove that ABCD is rhombus. We have to prove that ABCD is rhombus. ABCD is a rhombus. Now you take the triangle OAB and ODC, right? In triangle OAB and triangle ODC. In triangle OAB and triangle ODC, you know that it is given that OA equals OC and also OB equals OD, right? OA equals OC, OB equals OD. These two are given. So you write the reason what they are, how you got, that is given. Next, you got 2 pairs of sides here. Next you can have that here there is a angle made by them, angle AOB. Angle AOB is equals to angle COD. Why they are equal? Because you know that these 2 angles are the vertically opposite angles. Here the lines AC and BD intersect at O and they are the vertically opposite angles, and the vertically opposite angles are always equal. So you write they are, how they are equal? They are vertically opposite angles. Vertically opposite angles. Now you can write that according to Sss postulate, Sss congruence rule, right? Therefore, triangle OAB is congruent to triangle OCD. According to which congruence rule? Side angle side. See here, side angle side. Here also side angle side. According to Sss congruence rule. Then you can write here AB is equals to CD. Why they are equal? According to CPCT. Therefore you write AB is equals to CD. Reason CPCT. So you consider this is first. Here you proved AB is equals to AC by taking these 2 triangles. Now you take these 2 triangles. In triangle AOD and triangle BOC. In triangle OAD you take. In triangle in triangle OAD and triangle OBC. Again you write here, what is there? AO equals OC and OD equals OB. So you write AO equals OC or OA equals OC, OD equals OB. OA equals OC, OD equals OB. Reason? Same reason, that is given here. Diagonals bisect each other at right angles. That OD equals what? OB. Reason? That is given. Then also you write angle AOD equals angle BOC. Reason? Same reason, that is they are vertically opposite angles. Vertically opposite angles. Therefore you can write triangle OAD is congruent to triangle OBC according to Sss Congruence Rule. So you write by Sss Congruence Rule. The reason is Sss Congruence Rule. Therefore you can write what? AD is equals to BC. AD is equals to BC. Same reason, that is CPCT. So consider this is a second. And from first you got AB is equals to CD. And from second you got AD is equals to BC. And by taking these two triangles, you can prove that here AB is equals to AD. You take these two triangles, triangle AOB and triangle AOD, and here you know that DO is equals to OB and these two are equal, and also here the angles are 90-degree angles. It is given and common side is there. Then also you can prove here, as these two are equal means then you can have all the four sides are equal. That also you write in triangle AOB and triangle AOD. First here common side is there. AO equals AO. You write that is the common side. Write that AO equals AO, common side. Common side. And DO equals OB. Or here AOB, triangle AOB is taken first. So you write BO equals OD. That is also given. And also you know that here angle AOB equals angle AOD. Both are given that they are right angles, 90-degree. That is also given. Therefore you can write what? Triangle AOB is congruent to triangle AOD according to which congruence rule? That is SAS congruence rule. SAS congruence rule. Now consider here, therefore you can write that AB equals AD. AB equals AD. That is the third one. So here know that AB equals DC, that you have proved, and also AB equals AD proved, and this AD is also equals to BC. So you can write from first, second and third all the four sides are equal. Here in the first one what you have proved? AB is equals to CD. Second what you have proved? AD is equals to BC. Third we proved AB is equals to EC. So AB is equals to AD is equals to DC, BC, and also AB is equals to CD. Therefore, you can write from first, second, and third. You can write what? AB is equals to AD is equals to also BC, and AB is equals to what? DC. AB is equals to DC. So you can write, therefore ABCD is a rhombus. ABCD is a rhombus. ABCD is a rhombus. In this way, you got the proof that if in a quadrilateral diagonals bisect at right angles, then that quadrilateral is a rhombus. The fourth question show that the diagonals of a square are equal and bisect each other at right angles. Bisect each other at right angles. Here given that the given figure is square, and what you have to show? The diagonals of a square are equal, first thing. Second one thing, they bisect each other, and also they bisect each other at right angles. So let us consider ABCD is a given square and the diagonals are AC and BD. They intersect at O. So we have to prove that bisect each other means AO is equals to OC we have to prove, and also DO is equals to OB we have to prove, and the angle at O must be proved that they are right angles. 4 angles are there, we have to prove that they are right angles. Now here to prove that AC equals BD, diagonals are equals, you can prove it easily by taking the triangle ABD and ABC. If you prove that they are congruent, then you can write AC is equals to BD according to CPCT. So first you write what is given here, write the solution. So what is given here? Given a square ABCD, a square ABCD whose diagonals AC and BD intersect at O. Intersect at O. Here ABCD is a square, AC and BD are its diagonal, they intersect at O. Next, what you have to prove? We have to prove that diagonals are equal and they bisect at each other, right? And first you know the properties of square. What is that properties of square? All sides are equal. All sides are equal. And all angles are equals to 90 degree, that you know here. So what you have to prove here? We have to prove that AC equals BD, diagonals are equal. We have to prove that diagonals are equal. That is AC is equals to BD must be proved. Next, they bisect each other at right angles. They bisect each other at right angles. Means bisect means you can write OD is equals to OB. That is right. That is OD is equals to OB. OA is equals to OC. And at right angles means you must write that AC is perpendicular to BD. AC is perpendicular to BD. This much is to be proved here. To prove the first part, the diagonals are equals. That is, to prove AC equals BD, you take the triangle ABD and triangle ABC. Right? To prove what? Diagonals are equal in triangle ABC and triangle BAD. And triangle BAD. They are the triangles on the same base AB. So you will get a common base, common side here, and the equal sides which are opposite. And you take here which are equals. You write that AB equals AB. AB equals AB. Reason, that is the common side. Common you write. And also BC equals AD. BC equals AD. Why they are equals? BC and AD are equal. Why? They are the sides of square. In square all the sides are equal. So they are the sides of square. Sides of square. So they are equal. Next one you can write angle A means angle DAB. Angle B means angle ABC. So we write angle ABC equals angle BAD. You know what is the measurement of each angle in the square? All angles are right angles. They are equals to 90 degree. That is also you can write angles of all angles of square are right angles. 90 degree. So they are the angles of the square, and in the triangle ABC and triangle BAD, they are the angles of the triangle ABC and triangle BAD. So you write therefore triangle ABC is congruent to triangle BAD according to which congruence rule? So you know that S side, this is also side, angle made by them, that is SAS congruence rule. SAS congruence rule. So you can write SAS congruence rule. According to SAS congruence rule, you got that triangle ABC is congruent to triangle BAD. Then, as you proved that triangle ABC is congruent to triangle ABD, you can write AC is equals to BD. AC is equals to BD according to CPCT. CPCT. You got the first one, the diagonals are equal. Here you proved the diagonals are equal. Next, to prove that the diagonals bisect each other, to prove AO equals OC and OB equals OD, you take these two triangles and prove that they are congruent. If you prove that they are congruent, according to CPCT, you can write what? OA equals OC and OB equals OD. So you write the names of the two triangles and prove that they are congruent. So you write the names of the triangle. Is that triangle OAB in triangle OAB in triangle OAB and triangle OCD in triangle OAB and triangle OCD. Here AB equals DC. They are the sides of square. You can write AB equals DC, sides of square. Sides of square. And also you can write that the angle angle ABO must be equals to angle ODC. Angle, which angle? Angle ABO must be equals to angle ODC, and also this angle and this angle. Angle OAB must be equals to angle OCD. Angle OCD. Common reason you can write, they are the alternate angles made by the transversal of parallel lines. Alternate angles made by the transversal of parallel lines. Here you know that angle OAB is equals to angle OCD. It is like this way. Here OAB is equals to OCD. Here you will get the, as these two lines are parallel. And next, here the angle ABO and ODC are like this way. Here C and A are the vertices, here D and B are the vertices, and you know that these two are parallel. So they are the alternate angles made by the transversal of parallel lines, so they are equal. That you have learnt in 8th standard, also in the 9th standard. Now you take that the triangle, therefore triangle OAB is congruent to triangle OCD according to which congruence rule? See here, the common side is there, and here DC, they are the angles at the ends of D and C, they are the angles at the ends of AB. So you can take according to ASA congruence rule, two angles and their included side. ASA congruence rule. ASA congruence rule. So you can write that here AO equals OC. AO equals OC, and also OB equals OD. OB equals OD. The reason is, here the common reason, CPCT. CPCT. And you got that diagonals bisect each other. And here we have to prove that diagonals bisect at right angles. Means we have to prove that at a point O, the angles are right angles. That you have to show here. To show that, write the names of the adjacent triangles. In triangle AOB and triangle AOD, in triangle AOB and triangle AOD. So first thing you write AO equals AO common side. AO equals AO common side. So that is the common side of both the triangle. And also you can write AB equals AD because they are the sides of the square. AB equals AD, sides of square. Sides of square. And also you can say that here the angle, and you proved BO is equals to DO, and you write BO is equals to DO. It is proved. Here we proved that already diagonals bisect each other. So it is proved BO is equals to DO, proved. Now you can write, therefore triangle AOB is congruent to triangle AOD. And you need that angle AOB must be equals to angle AOD. Angle AOB equals what? Angle AOD. Here which congruence rule? You know that all our sides means SSS congruence rule. So we can write SSS congruence rule. Here as angle AOB is equals to angle AOD you got, that is according to CPCT, corresponding parts of congruent triangle. So you got that angle AOB is equals to angle AOD, but you know that here DOB is a straight line, therefore angle AOB and angle AOD is a linear pair. Their sum must be equals to 180 degree. You take, but angle AOB plus angle AOD equals how much? 180 degree. DOB is a straight line and here there is a linear pair. So here therefore you can take that. Therefore angle AOB equals angle AOD. Both must be equals to what? 180 degree by 2. So you got that angle AOB equals angle AOD. Both are equals to 90 degree. Therefore you can say that here AO is perpendicular to DB. That is nothing but AC is perpendicular to DB. So that is, thus you write, thus AO perpendicular to BD. So what you got? AO perpendicular to BD, that is nothing but AC perpendicular to BD. That is AC perpendicular to BD. In this way you proved that, what you proved first? Diagonals are equal, diagonals bisect each other and they bisect at right angles. Therefore you write, therefore we got what we got? We proved that, hence you write, hence AC equals BD, and also we got OA equals OC and OB is equals to OD and AC perpendicular to BD. So what you proved? The diagonals of a square are equal. AC equals BD we got, and they bisect each other. AO equals OC, OD equals OB we got at right angles. They bisect each other at right angles, means AC perpendicular to BD also we got.